Next, we will impose that expected value of delta 4 and this is 3 times sigma to the power 4. No, I'm sorry. Delta t squared. Because for normal distribution, for it means 0, expected value of the fourth power is 3 times variance squared. Okay. Or standard deviation to the power 4. So that means pu times u to the 4 plus pu times u to the 4 equals 3 times delta t squared. So I have 2 equations. It says 2pu u4 and the other equation is 2pu u squared this is equation 1, 2, divide 1 by 2 so this basically says PU's cancel out, U square equals 3 times delta T. Okay? I'm basically dividing the first equation by the second equation. Since they are, 2 sides are equal, I'm dividing the left-hand side by the left-hand side of the second equation, right-hand side by the right-hand side of the second equation. Hence, U must be square root of that. Well, going back to the first equation, or using this, 2pu u squared equals delta t, or 2 times pu times 3 delta t equals delta t. Equals 1/6, which implies PL equals 1/6 and PM equals 2/3. So I know exactly what probabilities they are. The up movement is going to happen, up and down movement are going to happen with a probability of 1/6. The middle movement is going to happen with a probability of 2/3. And for X, U equals so let's call this D. So if we construct the X3, this is X0, then I apply that transformation to the current price, I'm going to get X0. Remember, X0 is log of S0 minus R minus 1/2 sigma squared, which is something we can easily calculate in Excel or VBA, whatever we're going to do. So whatever that X0 is, let's start here. with 2/3 probability. It's going to stay the same. This distance is d. And this distance is also. And these happen with probabilities of 1/6. We're going to come to that probabilities later on, but for now, let's think about that. But the next movements are simple. Let's make it a different color. Let's see if you can see the light green. Okay. On those, they're going to stay the same, except you're going to add new extremes. But this is also D. Okay? From any what we call node, you can only stay the same for X, go up by D or go down by D. This is the reason I did that transformation. It makes the construction of the transform tree very simple. In fact, we're going to kind of tag those nodes by integers. So if I say xij, so let's call that x00, where I is the time period and j is the branch. Okay. And let's have I equals from 1 to n. I'm going to divide that time period from 0 to t into n subperiods. And j is going to be actually from negative I to positive I, including 0. Think about it. At the base, you have only 0. At period 1, think of this as negative 1, 0, 1. Negative 2, because this value is going to be negative 2d, right? Negative d, 0, 1d, 2d. The next one is going to be okay. Negative 3d, negative 2d, negative d, 0, 1d, 2d, 3d. So xij actually will be j times d. That's it. Regardless of I, but number of j's is limited by that. So constructing that tree is going to be extremely easy once we do the array stuff in VBA. Once I have the tree, calculating xij, Sij is going to be simple. Just unwind this transformation, which is not difficult. Solve that for x, which means sigma x plus that thing, all the whole thing e to the power. E to the power sigma xij plus r minus half squared